It's something we all take for granted. We turn on our faucets and a safe, reliable source of water is there for us anytime, day or night. What most people don't know is all the hard work and dedication that goes into supplying you with fresh, quality drinking water. Come along with us as we journey through the process of where our drinking water begins and how it gets to your tap whenever you need it. Rivers, lakes, and streams. These are surface waters which are a primary source of water in Arizona. When it rains or snows, the precipitation either seeps into the ground or flows directly into a river or lake. Eventually, this runoff ends up flowing into the ocean. But not all of the runoff ends up here. Some of it evaporates on its way downstream. Thirsty wildlife also enjoy it, and some of the water is diverted and used by cities, towns, and industries along the way. When dams are built to store rivers' flow, a lake or reservoir is formed. These rivers, lakes, streams, and reservoirs are vital to our everyday life. The main uses for this water include irrigation, producing electricity, cooling equipment, agriculture, and drinking water. Of course, this also includes cooking, cleaning, bathing, and even recreational activities. Let's take a closer look at Arizona's two major water providers. The Salt River Project has been delivering water through 131 miles of canals in Arizona for more than 100 years. Because we live in the desert, we typically do not get much rain, so we need to bring water into cities and towns from other parts of Arizona. When snowfall in the mountains northeast of Phoenix melts, it forms small streams which come together to form the Salt and Verde rivers. This area is known as our watershed and covers approximately 13,000 square miles. The amount of snowmelt from our watershed varies from year to year. Since there is typically never a consistent supply of runoff, SRP constructed several dams along the Salt and Verde rivers, which created lakes or reservoirs to store the excess water. SRP controls the amount of water released from these reservoirs depending on whether we have a wet or dry winter. The reservoirs allow us to store the water for later use. When water is released from the storage reservoirs, it is then delivered to cities and towns through a series of canals. The Central Arizona Project, or CAP, carries fresh water from the Colorado River to millions of people in central and southern Arizona. CAP is a collaborative project that started back in 1922 with the federal government and the 7 states that share Colorado River water. After decades of lobbying, a bill approving the construction of the CAP canal was passed by Congress in 1968. Construction of the 335-mile-long project began in 1973 near Lake Havasu and was completed 20 years later just south of Tucson. Water in the CAP canal is lifted by 15 pumping plants almost 3,000 feet, so it can flow through the system by gravity. Approximately 1.5 million acre-feet, or 489 billion gallons of water, is delivered every year to nearly 5 million people in cities like Phoenix, Tucson, Mesa, Glendale, and Scottsdale. Today, about 1/3 of CAP's water is used by cities and industries. Farmers use about 1/4 of the water, and 1/10 goes to Indian communities. The rest of the water, about 1/3, is pumped underground to use in the future. SRP built several reservoirs along both the Salt and Verde rivers to store water during the hot summer months and when we get below average snowfall. There are 4 reservoirs along the Salt River: Roosevelt, Apache, Canyon, and Saguaro Lakes, and 2 reservoirs along the Verde River, Horseshoe and Bartlett Lakes. The major reservoir of the CAP system is Lake Pleasant. Other reservoirs that are important to CAP on the Colorado River are Lake Mead and Lake Powell. Lake Pleasant is a 15.5 square mile lake used to collect and store runoff from the Agua Fria River. CAP pumps water into the lake, filling it in the winter months and releasing water during the hot summer months. CAP and SRP release water each day from their reservoirs into a series of canals that carry water to the treatment facilities. Canal water is either used to irrigate crops or treated for use in your home every day. SRP also has hundreds of wells throughout Arizona that are an additional water supply. These wells can be more than 1,000 feet deep and can pump thousands of gallons of water every minute. Those wells can supply up to 1/3 of the water we need each year. Both SRP and CAP store water underground for future use in a process called recharge. One method of recharge involves flooding an area with water and then letting it settle and drain down through the soil. Recharging helps replace underground water supplies, which can then be pumped out and used at a later date. As you can see, groundwater is an important natural resource, especially in areas that don't have ample surface water sources, like much of Arizona. Even though you can't see it and may not even know it's there, one of our most valuable resources is the water beneath our feet. Depending on where you live, groundwater may provide a portion of the water delivered to you in your home, school, or workplace. Groundwater is a primary source of drinking water for some regions of Arizona. Many rural Arizona residents have their own private wells. Groundwater comes from precipitation that seeps down through the soil until it reaches rock material already saturated with water. This is known as the water table. Groundwater moves slowly beneath the surface and generally follows gravity at a downward angle. It can eventually seep into our streams, lakes, and oceans. Below the water table is an area consisting of materials that can readily store and transmit water to wells or springs. This is called an aquifer. Wells can be drilled into aquifers and the water pumped out and used for drinking water. Each aquifer makeup is unique, and recharging will not be the same for all aquifers. This is very important to know and must be considered before pumping water from a well. If water is pumped too quickly and draws down the water table too fast, the well will produce less water and eventually run dry. Managing our groundwater sources properly is key to ensuring that future generations have enough water. Balancing the amount of water pumped from an aquifer with the amount put back into it, or recharged, is referred to as achieving safe yield. Achieving safe yield can happen through a variety of ways, by rain and snow, or from SRP and CAP recharge efforts. Recharging the aquifers now ensures that there will be water for us now and in the future. Surface water that makes its journey from the mountains into one of the many canals eventually is diverted into a water treatment plant, where a whole new adventure begins. Water entering a water treatment plant contains lots of natural organic particles that stay suspended in the water. These particles make the water appear cloudy. This is often referred to as turbidity, which is a measurement of how clear the water is. The goal of the water treatment process is to decrease turbidity, making the water clear and removing any particles that may be harmful to us if we were to drink them. To accomplish this, chemicals are added to the raw canal water to bring the suspended particles together. This is called coagulation. Next, the water is gently mixed through a process called flocculation. As the water is being mixed, the small particles collide with each other and stick together, forming larger particles. The particles grow so large that they settle out of the water. From there, the water travels to a sedimentation basin, which slows down the water, causing the large particles to settle at the bottom of the basin where they can be removed from the water. Water flows out of the top of the basin into a filter to remove the remaining particles. The filtering makes the water clear, but it still needs to be disinfected to remove potentially harmful microorganisms. A disinfectant such as chlorine is added to the water and maintained until the water is delivered to homes and businesses. A small amount of disinfectant is required to be in the drinking water system. This is known as residual disinfectant. This is the most common type of water treatment, known as conventional water treatment. There are other treatment processes available. The goal of all treatment processes is to ensure a safe, reliable drinking water supply. Once the water is treated at the plant, it begins a third leg of its journey in the distribution system. The water distribution systems for any city or town are the pipes that carry the treated water from the plant to your home or business. The pipes can range in size from about 1 inch to more than 12 feet in diameter. Pipes going to individual residences are usually 1 inch in diameter. Water mains that carry a large amount of water can range from 4 inches to as large as 12 feet in diameter. But to keep the water continually moving also requires pump stations and valves, which help control the flow and pressure throughout the system. Probably the most common and visible element of a water distribution system are fire hydrants. Of course, fire hydrants are there to help fight fires whenever needed, but they also help maintain the water quality by helping flush the system when necessary. Another component of the distribution system is storage. Storage tanks are filled during the time of day when water usage or demand is low, typically while you're sleeping. So when demand is high, like when you're getting ready to start your day, there is plenty of water for you and your neighbors to use. Storage tanks also allow the distribution system to maintain proper flow and pressure during high demand times. Most water distribution systems are also connected electronically to an operations center. This allows for easier control of the valves, pumps, and storage tanks from a central location. From time to time, the pipes in the water distribution system can break or spring a leak. It's up to your city, town, or private water company to ensure breaks are kept to a minimum and to make repairs quickly. This helps conserve water, maintain water quality, and limit traffic restrictions on the road. Before your drinking water made it to your home, it traveled hundreds of miles where it picked up naturally occurring minerals and other substances resulting from natural processes as well as human and animal activities. Once your drinking water is in the distribution system, there's an entire team of professionals working hard to ensure your water remains at the highest quality. More than 1 million tests and measurements are performed each year on your drinking water to ensure the highest quality tap water possible. Your tap water is sampled and tested for nearly 100 different substances on a regular basis. The quality of your tap water is monitored throughout the year to ensure that it meets the rigorous standards set by the federal, state, and county governments. Some monitoring is done continuously throughout the day by meters at the water treatment plants. Other monitoring is done by staff throughout the distribution system. These professionals take samples at designated locations. These locations are selected to represent the water quality throughout each city's distribution system. The samples taken are collected and then taken to a laboratory where they are tested for a variety of substances and compounds. The frequency of samples collected can vary depending on whether the source of the water is surface or groundwater. How often sampling of a substance is required depends on the risk to people's health. Substances that are unhealthy or more common may be sampled more frequently. The utmost care is taken during sampling. All samples collected are put in sanitary containers and are labeled, preserved, and returned to the laboratory for further testing. The results of all monitoring and testing are available for your review. Each year, cities and towns send out a Consumer Confidence Report or Water Quality Report to customers, typically by July 1st. Most cities and towns have this information on their websites, and links to the results can also be found at tapintoquality.com. So now you know how much hard work and effort goes into each and every drop of water you use every day. Take comfort in knowing there are dedicated professionals working around the clock to ensure your water is safe to drink every time you turn on your faucet. To learn more about your drinking water, visit tapintoquality.com.